Hello guys, welcome back. I am Ranin Sen. In this lecture, we are going to start with inverter, which is most important power electronics device that is very frequently used for domestic purposes as well as commercial purposes also. Let us start with the definitions of the inverter. So inverter is nothing but it is a static device. It can convert one form of electrical power into another form of electrical power. So it cannot used for generate the electrical power. It is only used for the convert one form of power into another form of power. So inverter is a converter, not generator. So here DC power is converted into AC power at variable voltage and variable frequency. Let us move on the applications of inverter. The applications area of inverter such as adjustable speed AC motor drive. It is very useful for controlling the speed of an AC motor like single phase induction motor, three phase induction motor, etc. Second one is uninterrupted power supply. Without any interruption it can deliver the power. Third, running appliances of AC used in an automobile battery in power transmission industries. It is very useful because if you want to improve the power factor of a transmission line, so first we will try to compensate the reactive power, due to which we can improve the power factor and efficiency of a transmission lines also. Now, types of inverter. On the basis of sources, there are two types of inverter. First one is current source inverter, that is called CSI, and another one is voltage source inverter, that is called VSI. Current source inverter is a unidirectional and bipolar, and voltage source inverter is a unipolar and bidirectional. Let us see what is the difference between the unidirectional and bidirectional. Unidirectional means when it conducts current only in one direction, that is called unidirectional, and bidirectional means when it conducts current in both the direction, that is called bidirectional. Bipolar means when it blocks both the polarity of the voltage, that is called bipolar, and when it blocks only one polarity of the voltage, that is called unipolar. Current source inverter is a good short circuit protection, whereas voltage source inverter short circuit damages. In case of current source inverter, load current depends on source current and load voltage depends on load, whereas in voltage source inverter, load voltage depends on source voltage and load current depends on load. Now the next topic is single phase half bridge voltage source inverter, in which first we will try to understand the operation of the very first type of single phase voltage source inverter, that is called single phase half bridge voltage source inverter. This is the circuit diagram of the single phase half bridge voltage source inverter, in which we have to supply the DC voltage VDC by 2 and VDC by 2. Here load is connected. It could be anything like resistive load, inductive load and capacitive load. The polarity of the output voltage is already mentioned. The output voltage is nothing but it is a voltage across the load, and I naught is the load current which is flowing through the load. S1 and S2 are called the switches which is used for operating the devices. Okay, D1 and D2 are nothing but it is a anti-parallel diode. So at a time only one switch is operated. So in first half period of time, means for the duration of 0 to t by 2, S1 is on whereas S2 is turned off. When switch S1 is turned on for the time duration of 0 to t by 2, in this case the positive terminal of the VDC by 2 is connected with the negative terminal of the is connected with the positive terminal of the output voltage, and negative terminal of the VDC by 2 is connected with the negative terminal of the output voltage. So in this case output voltage should be same as the supply voltage, that is VDC by 2. Because why? Because the supply voltage, the polarity of the supply voltage and the polarity of the output voltage both are same. That's why the output voltage should be same as the supply voltage, that is VDC by 2. But when switch S2 is on, for the time duration of t by 2 to t. In this case, switch S2 is on but S1 is off. So in this case, the positive terminal of the supply voltage is connected with the negative terminal of the output voltage, and negative terminal of the supply voltage is connected with the positive terminal of the output voltage. So in this case, the polarity of the output voltage and supply voltage both are not same. That's why the in this case output voltage is minus VDC by 2 during the switching operation of S2. So now what about the current during the switching operation of S1? As we know that the current entering into the negative terminal and leaving from the positive terminal in case of supply voltage. So the current direction of the switching operation S1 is in clockwise direction, whereas during the switching operation of S2 the current direction is in clockwise, because during the switching operation of S2 the current entering into the negative terminal and leaving from the positive terminal. So during the switching operation of S1, the switch current I1 and load current I0 both are in same direction, but in case of switching operation of S2, the switch current S2 and load current I0 both are in opposite directions. Now when diode D1 is conduct, it reverses the switch current S1, okay, and when diode D2 is conduct, it reverses the switch current S2. So the anti-parallel diode does not change voltage polarity, but it reverses the current direction, okay, but it reverses the current direction. Okay, let us talk about the quadrant operation of switch S1 and S2 and diode D1 and D2 of single phase half bridge voltage source inverter. See, this is the quadrant operation of switches and diodes. So in this case, in the quadrant operation of switches and diodes, the switch S1 and S2 provides operation in first quadrant and provides operation in third quadrant, because during the switching operation of S1 the polarity of the supply voltage and polarity of the output voltage both are same. So the supply voltage should be same as the output voltage, and whatever the current is flowing from this supply voltage, it will flow in the same direction of the load current I0, okay. But during the switching operation of S2, the polarity of the supply voltage and the polarity of the output voltage both are opposite. But whatever the current is flowing from this supply voltage VDC by 2 during the switching operation of S2, it will flow in the opposite direction of the load current I0. So that's why the S1 and S2 provides operation in first and third quadrant. In both the quadrant the power is greater than 0, and power is greater than 0 means it will absorb the power, okay. But when diode D1 is conduct, it reverses the current of switch S1, but it does not change the voltage polarity. Similarly, when diode D2 is conduct, it will also reverses the switch current S2, but it does not change the voltage polarity. So that's why the diode D1 and diode D2 provides operation in second and fourth quadrant. In both the cases power is less than 0, so in this case it will deliver the power. Let's have a look at the waveform of output voltage and output current I0 V naught and I naught in case of purely resistive load. So in this waveform, Ig1 and Ig2 are called a gate pulse, which is just used for turn on the switch S1 for the period of time 0 to t by 2, and turned on the switch S2 for the period of time t by 2 to t. So in case of resistive load, for the period of 0 to t by 2, means in this period the output voltage should be same as the supply voltage, and output voltage is VDC by 2 during the switching operation of S2 and for the time period of 0 to t by 2. But during the switching operation of S2 and for the period of time t by 2 to t, in this case the output voltage is minus VDC by 2. Okay, or when we are going to talk about the load current of resistive load, okay, so the current flowing through the resistive load is I naught. When we are going to divide the output voltage by resistance, then we will get the magnitude of the output current. So the magnitude of the output current in case of resistive load is VDC by 2R for the period of 0 to t by 2, and minus VDC by 2R for the period of t by 2 to t. So in case of purely resistive load, the waveform of the load current is same as the waveform of the output voltage, but the main difference is that the magnitude of the output current is less as compared to the magnitude of the output voltage. Okay, let us talk about the waveform of output current I naught in case of purely inductive load and RL load. See, in case of purely inductance load, means L load, current is linearly increases from minimum peak current, means minus IP, to maximum peak current plus IP for the time period of 0 to t by 2. Similarly, for another time period, means t by 2 to t, it will linearly decreases from maximum peak current to minimum peak current, means plus IP to minus IP. So as we can see that the waveform of the output current of purely inductance load I naught is symmetric about t-axis. Why it is symmetric? Because at output DC component is 0. So that's why current is linearly rise from minimum peak current to maximum peak current. Okay, so for the time period of 0 to t by 2, diode D1 is conduct in 0 to t by 4, because during the switching operation of S1, the direction of the diode current D1 and the direction of the load current I naught both are in opposite directions. So that's why diode D1 is conduct for the time period of 0 to t by 4, and switch S1 is conduct for the time period of 0 to for the time period of t by 4 to t by 2, because for this time period the current direction of switch S1 and the current direction of load current I naught both are in same directions. Okay, so that's why D1 is conduct for the time period of 0 to t by 4, and S1 is conduct for the time period of t by 4 to t by 2. Okay, when we are going to talk about the another time period or during the switching operation of S2, okay, in case of purely inductance load, so diode D2 is conduct for the time period of t by 2 to 3t by 4, because for this time period, or we can say that during the switching operation of S2, the diode D2, the direction of the diode current D2 and the direction of the load current I0 both are in same direction. So that's why D2 is conduct for the time period of T by 2 to 3T by 4, and switch S2, the direction of the switch current S2 and the direction of the load current I0 both are in opposite direction. So that's why the switch S2 is conduct for the time period of 3T by 4 to T. Okay, now let's have a look how can we calculate the peak current IP. As we know that the expression of the inductance voltage is L di by dt, but for the time period of 0 to T by 2 or during the switching operation of S1, the output voltage, the magnitude of the output voltage should be same as the supply voltage. That's why the output voltage is VDC by 2. But for the time period of T by 2, the change in current is how much? The change in current is IP minus of minus IP. So we will get the value of due to this expression we will get the value of the peak current, and that is equals to the VDC by 8 FL, where VDC is the DC supply voltage and F is the frequency and L is the inductance. Okay, now in case of RL load, the current is linearly the current is exponentially rise from minus IP to plus IP. So in this case also, similarly in this case also, the diode D1 is conduct in 0 to T by 4 and S1 is conduct in T by 4 to T by 2, and for another time period of T by 2 to T, diode D2 is conduct T by 2 to 3T by 4 and switch S2 is conduct in 3T by 4 to T. See, for any type of load, whether the load is inductive, whether the load is resistive, inductive or capacitive, whatever the load is occur at output side, the output voltage waveform will remain same, but the current waveform depends on the nature of the load, and the waveform of the current will different according to the load. So let us see how can we calculate the RMS value of the output voltage. So for the time period of 0 to T, when we are going to integrate the square of the magnitude of the output voltage VDC by 2 for the time period of 0 to T by 2, and plus when we are going to integrate the magnitude of the output voltage square of magnitude of the square of the output voltage minus VDC by 2, and then when we take the root of this expression, then it will come out to be Vs by 2. So RMS output voltage, okay, is Vs by 2. Okay, now as we know that the waveform, the Fourier expression of the square waveform is what? The Fourier expression of the square waveform is summation of n equals to 135 to infinity 4 V0 by n pi into sine n omega t. Okay, because the waveform is half wave symmetric, that's why it will only exist for odd harmonic, it will not exist for even harmonic. So that's why n is 135 up to infinity. V0, the magnitude of the output is how much? VDC by 2. So by this expression the output voltage will come out to be 4 into VDC by 2 upon n pi into sine n omega t. Then it will come out to be 2 VDC by n pi, summation of n equals to 135 up to infinity to VDC by n pi sine n omega t. Okay, so this is the expression of the Fourier expression of the square wave output voltage. Okay, so this is all about the single phase half wave voltage source inverter.